So we talked about testing method yesterday, right? So black box, white box, gray box, and all. So today we are going into like the levels of testing, like in a project. So what are the actual testing we do? So that's called basically levels of testing, right? Yeah. So basically in a software project in SDLC, these are the four levels that will be done, right? One is unit testing, then integration testing, then system testing, and acceptance testing. So these are the four levels. So for any project, so these are the four different levels of testing that is done, right? So this is the diagram that shows the flow, right? First unit testing will be done, then integration testing, then system testing like functional testing or non-functional testing, then regression, then finally the user acceptance. So user acceptance is basically the end users will do. So the integration testing is integration between different modules. So we're going to talk about each of these testing methods in deep. So system testing is functional, non-functional in the sense can be performance, security, all those things. Regression is the full application testing, right? We're going to test all the features in the application for each release. So that is a regression testing. So we'll talk today about unit testing and integration testing, and what are the different techniques for unit testing and what are different.
When regression testing will done?
Yeah, unit testing is just the beginning when the developer completes the code. So mostly the developers will add some unit testing cases inside the code itself, right? Before it gets released for testing, so they do some kind of unit testing. So that's the first stage in the development itself. Once they written the code, they will do that unit testing. That's the first test, right? So this is unit testing, right? So we'll talk about unit testing. So it's basically a type of software testing where individual units or components of the software are tested. So the purpose is to validate each unit of the software code performs as expected. So here we are validating each unit of the software code, like whatever program they written. There may be multiple units of programs. So each program is tested and validated, right? So basically unit testing is done during the development, like coding phase. Right? If you look at software development lifecycle, at the part of coding phase, we do that unit testing. So mostly done by developers, right? So unit test isolates section of the code and verify its correctness. So it's not going to test the module level. It's done at a program level. So you see one module can have multiple programs, right? So this testing is done at a program level, like something like an individual function, a method, procedure, right? A small module or an object. Right? These are development terms, right? These are development terms. So mostly done by developers. So you should be aware of this unit testing part, right? Who is doing, and you may ask for like sometimes unit testing results, they generate some reports from unit testing so that you can see what are the various unit tests done for the program, right? So general idea, this is why it is important, right? So the more code you write without testing, the more paths you have to check for errors, right? So if some code is not tested, there is a chance for more errors in that code. So if they add more unit testing, there will be less errors. So that is the goal of unit testing. So there is like 3 or 4 different programs. So we need to test all different paths for that in that program, right? So there will be certain kind of techniques to test that. So I will explain that concept. So it basically helps you fix bugs early in the development and save costs. So it helps developers to understand the code base and make changes quickly. So good unit tests are also serve as project documentation, right? So if you have like a good unit test, they will get like unit test report that can help like generate project documentation, and they have like code reuse. So that is development terminology, right? There is some ways to do like unit testing. So these are some of the code coverage techniques used in unit testing. So what is code coverage? I told you, right? Like if you have like there is 100 lines in the code, like 3-4 functions and 100 different lines. So when you test all the 100 lines in the code, so that is 100% code coverage, right? If you test like 50 lines in the code, that is 50% code coverage. So that is how they measure like unit testing percentage, how much percentage of code is tested. So there is a different ways to test unit testing coverage. So one is called statement coverage. Statement in the sense, suppose you have like some assignment operation, right? Like something like C equal to A plus B. That is a statement in coding language, right? So one is that statement coverage. Then there's a decision point, like something like if-else condition, right? If something is true, there is one function that gets executed. If it is false, some other function gets executed. So that is the decision coverage, right? So there will be testing to cover the both positive true scenario and false scenario. So that is a decision. Then the branch, right? So if there is some value, so it can go into 3 to 4 different conditions, right? So maybe like for value 0, one function value 1, one more function value 2, another function, right? So that's a branching coverage, right? From the main code, it will go to different branches, right? So that is the coverage of branching. Then condition coverage, and there is something called state machine. State machine in the sense like code sometimes go from one state to another state, right? That's a part of like development logic. Like there will be different states in the program. So that is another method to increase the unit testing coverage. So these are like various techniques. So basically, like when there is a code, so we want to cover like different flows, right? So if you are familiar with some function or procedure, there will be for loops, if loop, if else conditions, while loops and all. So it's going to test all those conditions as part of unit testing. So when code coverage increases, the quality increases. So that's the main goal in the unit testing. Right, so these are like basically development tools that will be used for unit testing. So I don't know if you are guys familiar with these unit testing tools. They're basically used for generating unit tests. So something like if there is a code that is getting written in Java programming language, there is a tool called JUnit, right? So that is used to create unit tests and all. So it's at the coding level. If somebody is using like .NET in the development project, there is something called NUnit, right? So that will generate unit tests for the code. Similarly, like JMockit is there. This is another unit testing tools. So these tools, they keep on changing based on the project and what they think is the best fit for the that particular project, right? There is some for Java. There is also something called TestNG. That is also another JUnit tool, unit testing tool, right? If somebody is doing PHP programming and all that, there is a PHP unit. That is a unit testing tool, right? So these are different types of unit testing tools. Normally, as a tester, we don't involve in it, but we just need to aware that what kind of tools they are using as part of unit testing and what is the code coverage. So generally people talk about this code coverage. What is code coverage and how much is the code covered in unit testing part and all that. So these terms will come in, right? And there is another concept called test-driven development. This is another methodology in unit testing. So in that, they first write the test before writing any code, right? So that way, initially the test will fail, but once they write the code, correct code, the test will pass, right? This is basically another way of ensuring quality. It's a test-driven development method, right? So the tests are written before the code, and basically it relies heavy on testing frameworks. So all classes in the applications are tested. So once you write the test first, then write the code, basically you are testing all the code that is written, right? So that's the easy way to ensure quality of this code that is written, right? So quick and easy integration is made possible. So this depends also on the what particular project and all, whether they are following this strategy or not, right? Not everybody will follow this strategy because it needs additional effort from developers to write extra tests along with the code, right? So maybe once you go into a particular project, so if they're following this methodology, so you should need to understand that this is the way they're going to write the code, right? They're going to write test first and then write actual code and all that. Right? This is a different way of ensuring quality and all. So that is the unit testing part. Any questions on this unit testing? Okay. So let's go to the integration testing, right? This is what testers will do, right? So what is integration testing? This is basically defined as testing where software modules are integrated logically and tested as a group, right? If you have multiple modules in the project, so we're going to integrate and test it as a group, right? So that is integration. There you can see different functionality, right? So typically software project consists of multiple software modules coded by different programmers, right? So purpose of this level of testing is to expose defects in the interaction between these software modules when they are integrated, right? Like let's say, suppose a banking application, right? So there will be one login module and there is one for account maintenance, right? There will be one for report generation. So there will be different modules. So each module is coded by different programmer, right? So our goal is to integrate, test all the modules when they interact with each other, right? That is part of integration testing. So this is basically how it is performed. Integration testing. So assume you have 4 modules. So we're going to connect each other and test the communication part. Like there will be data flow between one module to other module. Like there will be functionality based on how the one module responds and all that. So that will be integration testing. So integration test case differs from other test cases in the sense it focuses mainly on the interfaces, and flow of data and information between the modules, right? So we have like login module, account module, reporting module. So somebody cannot access account and reporting modules without logging into the application, right? So you have to see that only logged in users can access, say, account module or report module. Right? So we need to test that. So if somebody is not logged in, they cannot access the other two modules. So that is the interface, right? So basically, so once logged in, they're going to send some code to the other modules that this user is logged in, so that other two modules are accessible, right? Something like that, right? So here is priority is given for integrating links rather than unit functions which are already tested, right? So individual modules are already tested either by testers or developers. So we are trying to integrate and test the application modules. Right, so sample integration test cases, right? So application has like 3 modules, say login page, mailbox, and delete emails. So each of them is integrated logically, right? This is one example. Login page, say suppose your mailbox and delete emails, 3 different modules. So once you log in only, you can access the mailbox. And once you are in the mailbox, then only you can delete an email, right? So that is the interlink between modules. So that is the integration testing. So there is a different approaches to integration testing. So like how,
Hello. So who is responsible to do integration testing?
this is testers, right? That is the part of testing team to do the integration testing. Right, only the unit testing is developers. After that, integration testing, system testing is the actual testing team that is going to do.
Okay, sir. Thank you.
Yeah. And so when you integrate modules, so there is different ways to test it. So these are like different testing methodologies, how integration is done. So one is Big Bang testing. So it's basically a testing approach in which all components are integrated together at once and tested as a unit. So if you have like 4 modules, so all of them are integrated and they execute the tests, right? So this is like a Big Bang testing. So this is easier for small systems. So if the functionality is less, right, then you can integrate all of the modules and test it, right? And so what are the disadvantages? Fault localization is difficult. Like if there is some problem, so it is not easy to find which module has the problem and all that. So given sheer number of interfaces that need to be tested, some interface links to be tested could be missed. Like we have like more modules to test, so you may miss some of the communication between some modules, right? Maybe like there is like 10 modules. So if you do like this approach, sometimes you miss some of the communication between some of the modules, right? Based on the scenarios you execute and things like that. Since integration can commence only after all modules are designed, right? Because this testing method needs all modules to be ready before we start testing. So we need to wait for all modules to be ready, right? So the testing team will have less time for execution in the testing phase, right? So you'll have less time to test all the features, right? Because everything is ready. So there will be more pressure on the testing team to finish the testing part, right? So you'll get less time to execute the test cases. So since all modules are tested at once, high-risk critical modules are now isolated and tested on priority. So there may be some modules in this group which has high risk in the sense it has critical functionality and maybe it has more issues there. So we cannot clearly test separately those modules and isolate it. So that may leave some issues in the system, right? Peripheral modules which deal with user interfaces are not isolated and tested on priority. Right? Basically, there is no testing of individual modules. So there is a chance for issues and some of the defects you cannot find using this kind of method. Right? This is the Big Bang testing method, because we need all components to be ready before we start testing. So that may leave some issues unidentified or not able to find issues. There is less time to execution and all that stuff, right?
Sir, is Big Bang testing and integration testing are same?
Yeah. So these are all part of integration testing. So this is the integration testing. Basically, we are testing all modules. Inside integration testing is a different approach, right? How do you do integration testing, right? So whether you do all modules at once, or we'll do one module first, then next module, like integrate two modules or test, then go integrate another module and test. So these are the different techniques in the integration testing itself, right? So basically, this is one of the testing technique. How do we do integration, right? So these are all part of the integration testing. So whatever techniques I'm discussing now, they're all part of the integration testing. So this is a
Okay, sir.
different way of testing modules, right? And then the next one is incremental testing, right? So this is also integration testing method. So this is another way to do integration testing. So in this, we want to integrate two or more modules that are logically related and then test for proper functioning, right? So in the Big Bang, we are integrating all the modules and then testing. Here we are testing related modules first, right? So two or more related modules first, then test those functions. Then other related modules are integrated incrementally. Like you test first two or three modules, then once those are working, you want to add other modules and then test, right? Suppose you have like 10 modules, so you're going to test first three modules, then add fourth one, then add fifth one, like that. Right? That's the incremental testing. Right? So in incremental testing also, there are two types, bottom up and top down, right? So you, like, these modules can be grouped into a hierarchy, which one is first, which one is last. So you can start from the first module, or you can start from the last module. Last module to the first one, or first module to the last one. That is called bottom up and top down. So these are all like integration methods only. So let us see what is, we'll show you that. And there is another method called Stubs and Drivers, right? So Stubs and Drivers are dummy programs in integration testing. So this is also a part of integration testing, right? This is another method, another technique. So basically, if there is some missing module, so they will write some dummy module for it, right? So if that module is not ready yet, so they'll just put some dummy code just to send some correct response to the other modules. Then they test whatever is ready, right? So basically, stub is called a module under test. Suppose you are testing module 2, so that module is called as stub. Driver calls the module to be tested. The first module will probably call the second module, which is under test, right? The stub and driver method. So here, like, even some of the modules are ready, not ready, right? You can still test it. So that is the advantage with this method, right? So it depends on, like, each project, they will define what type of testing they want to do. So based on the project requirements and testing team, right? So, but you should be aware of what type of different techniques for integration testing, right? And so here is like a bottom-up integration testing. So bottom-up integration testing means you test low-level modules first, then the higher-level modules, right? So low-level modules first, then go for higher-level modules. So this process continues until all modules at top level are tested, right? So there is levels in each of the modules. They are organized into different levels based on like importance or priority, right? You're going to start testing from lower level to higher level. So this is a like step-by-step approach, right? So basically, so you can easily find issues in the modules because you are testing set of modules first, then adding other modules. So you know, like if you test module 1, it is good. So if you add module 2 and there is some issue, so we know like there is some problems between module 1 and 2, right? So, but if you test module 1 and 2, they are good. So we add one more module and there is new issues, then we know like module 3 has some issues that needs to be fixed, right? So that way you can easily find issues. So there is no need to, no time is wasted for waiting for all modules to be developed, unlike Big Bang approach, right? So in the Big Bang approach, you need to wait for all modules to be developed. So here there is no need for waiting, right? You can test whatever is ready and raise the issues, right? So what are the disadvantages? So critical modules at the top of software architecture. Suppose like there are important modules at the top level, you're going to test it in the last, and so probably you try to find the defects at the very end, right? So that is a disadvantage. So an early prototype is not possible because all the modules may not be ready. So you don't know like if all the features working or not, right? For each method, there will be always some advantages and disadvantages. So based on the project, the either test manager or somebody will say, we'll follow this kind of process for the integration test. So this is how the approach for bottom-up integration, right? So it's a module 1, 2, 3, 4, 5, 6. There are 6 modules. So when you're doing bottom-up, you're going to test 4, 5, 6 first. So once those are working, we add 2 and 3, right? So then if all these 5 are working, you're going to add module 1. So that is how is the bottom-up approach, right? Then there is another called top-down. So here you're going to do the reverse, right? So top-down is basically you do the other way. You start from higher level and go to the lower level. So this is also, there is some advantages. Here also you can see which module is failing first, because anyway you're testing modules one by one. And there is a possibility to obtain early prototype. So we are testing from higher level. So maybe higher level has important features, important modules first, right? So though you're going to get better prototype, right? The better like important features working first in the top-down approach, right? The bottom-up approach, the important modules are tested in the last. So basically the critical modules are tested on priority. So you can find major design flaws at early. So you can find early important features. If there are issues, you can find it early, right? So what are the disadvantages? Needs many stubs, right? Because the lower level modules, if they are not ready, so they have to create some kind of dummy programs to simulate that functionality, right? And so lower level modules are tested inadequately. So we're going to test them in the last. There may not be less time to test lower level modules and all, right? This is a top-down approach. And so basically this is how it will be done. So you're going to start with module 1 first, and module 2, 3, and 4, 5, 6. Right. So whichever is in the top has important features, like critical functionality or important features that will be there. Right. So So like we discussed like 4 techniques, right? One is Big Bang, then incremental testing. So incremental testing, basically this bottom up and top down, then stub and drivers, right? So then there is another method called
Sir, what is the difference between stub and driver?
the stub and driver is, say one module is ready. The other modules will create it as a dummy programs. So the other modules are not ready, right? So create some dummy program. Dummy
Okay, sir.
which will just give the response to the whichever is ready. So we'll test only that module, but other modules which are not ready, we'll just use it for testing purpose.
Sir, and what is driver, sir?
Yeah,
What is driver, sir? Driver is also used for the same task.
driver is a dummy program, right? Stub
Okay.
is the work which is actually ready, which is under test.
Okay, okay, sir. Thank you.
Dummy program in the sense they'll just write some
Yes, yes.
simulator kind of code, yeah, which is not the real code.
Okay, sir.
Okay. Then we have this, so in between, so we have top down and bottom up. So there is something called sandwich method, which has hybrid kind of approach, right? So here, so sandwich testing is a strategy where top level modules are tested with lower level modules at the same time, and lower modules are integrated with top modules and tested as a system. So it is a combination of top down and bottom up approach. So that is called like hybrid integration testing. So it's a mix of top down and bottom up approach to benefit functional testing, right? Find more issues early in the testing process. So we are so talking about this sandwich testing, which is a mix between top down and bottom up. So this is how it works. So it's kind of a hybrid model. So instead of testing only from lower level and higher level, we're going to do mix of higher level and lower level. And then, so whichever is not ready, they're going to use some stub, right, dummy program to test. So that way, so you can easily find more important issues at the early stages and all that. So all this, mostly the test managers or test leads will generally decide what kind of testing, so what kind of technique we need to use for the integration testing. So based on that, so we'll be executing the test cases, right? So those are different testing techniques. Then here is a general plan how to do integration testing, right? So what is the strategy to do integration testing? So this is a general outline, right? So initially you're going to prepare like an initial test plan, integration test plan. Then we're going to design test scenarios, test cases, and scripts. Right. So we'll be talking more about this test cases, test plans, and all that in the coming sessions. There is something called software test life cycle as well. So just like we have like a development life cycle, there is a test life cycle as well. So in the test life cycle, we're going to talk about all this test plan, test scenarios, test cases, test scripts, and all that. Then the executing the test cases and following by reporting defects. So defects are basically the issues we found during testing process, and tracking and retesting of defects. So once we raise defects, the development team is going to fix them. So we're going to track those defects and retest them, right? So these steps keeps on repeating until the integration is successful, right? So this is the general integration process. So there's a test plan, there's a test scenarios, test cases, and scripts. Then execute the test cases. We're going to generate the report like how many passed, how many failed, and what are the issues, right? So then we're going to track and retest the defects and repeat the whole process again. That's the general integration plan. And so there is something called entry and exit criteria, right? So what is entry criteria and what is exit criteria? So entry criteria is basically when we start testing the integration testing, that is entry criteria. Like something needs to be done before we start integration. And exit criteria is when we say like we finished integration testing, that is exit criteria, right? So the entry criteria for integration testing is unit tested components or modules, right? So unit testing should complete for the all components or modules, and all high priority bugs are fixed and closed. So suppose you already did one round of testing, we raise some issues. So they need to close the bugs and fixes before we start integration again, right? So all the modules to be code completed and integrated successfully, right? Then we should have these things to be ready, right? Integration test plan, test case, and scenarios to be signed off and documented, right? Before we start testing, we're going to prepare all these plans, like test plan, test cases, and scenarios. So those documentation will be reviewed by like project team or test manager or development manager, and they will sign off, right? So these are all the different things we need to do as part of integration testing. So that needs to be ready. The documentation should be ready. Then required test environment to be set up for integration testing, right? We talked about test environment, right? Development, QA, UAT, and prod. So for integration testing, we need the QA environment to be ready, right? That should be ready before we can start testing. So without all these things, we cannot actually start the integration test, right? So if any of them missing, we cannot do the integration. That is the entry criteria. So that's when we start doing the integration testing and follow this plan. And what is the exit criteria? Like when we're going to say we are done with integration testing, successfully testing of integrated application, right? Executed test cases are documented. So we're going to say, we're going to execute all the test cases, and we'll say like what is passed and what is failed. So all the high priority bugs are fixed and closed. Technical documentation to be submitted, followed by release notes, right? So all the documents are ready for the project, and they're going to build a release notes. So release notes is nothing but various modules that are tested and which are ready to go into like next stage, like either acceptance testing or final production, things like that. So this is the integration testing process. So this is the main part in testing. Like this is where we sign off all the project modules, actual application from with integration testing, right? So then we have like system testing that we're going to discuss. So there's functional and non-functional testing and all. This we're going to talk, I think in the next section, because we have functional testing, non-functional testing that's related to performance and security. Then what is regression testing? And finally, user acceptance and maintenance. So user acceptance is where users actually will test. Maintenance is when we go into production and they keep adding new functionality or fix any errors that are coming up in the production system. That is the maintenance testing. So these three we want to talk in the next section, like system testing, functional, non-functional, regression, right? So these are, so you hear like a lot of methods, a lot of testing levels and all. So you need to understand these things before we do actual testing. Because so for each project, there is a different levels of testing that happens, right? So we need to understand what level, what type of testing is going on, and where the project is, whether the project is in the beginning stage or whether the project is in the middle, or whether the project is already live and they are doing maintenance, right? Depends on what kind of project, right? So different types of testing will be performed on that. So that is the session for today. So we just talked